5, 4, 3, 2, 1. Engines full power and liftoff.
And this is where the cool intro effects start.
The cool music sounds.
Nick said he might make us music because apparently he makes music.
What? Like Nikhil?
Nikhil, yeah.
What?
Like guitars, piano.
I find that very hard to believe.
Yeah, so
Wow. Okay.
before
Cool.
the sprint planning,
Mm-hmm.
me, Priya, and was it Devin? Someone else was there.
Yeah.
And Priya was like, "Oh, so how's the music coming along?" I was like, "Oh yeah, I asked an AI to make one," and then I played them, and they're like not all that great.
They're not great.
They're not great. And then Nick's like, "You didn't ask me?" I'm like, "I'm sorry, you make music?"
I know the exact face that he made when he asked you that too.
You could just see his eyebrows.
Yeah, exactly.
Yeah. So you're 22.8% done your life. Or what was the number?
24.8, which is crazy.
What is that counting up to? Like 75?
80.
So you're 21?
No. That doesn't...
19.
yeah, I'm 19.
Okay.
Yeah.
Okay, never mind.
Math is hard.
Maths.
Sometimes.
Maths. Yeah, that's such an interesting concept. I actually track how many days I have left too.
You got your week counter, right?
Yeah, how many weeks I'm alive.
Yeah.
But like I have my weeks in life poster.
Yeah, exactly.
And so I'm like, I mean, I can tell you the days.
You
It's
mean
in
my life in weeks?
my life in, did I say days?
No, my weeks in life.
My weeks in life. I'm currently 8,154 days old.
Wow.
Which, like, at 22, you'd think that number would be bigger. But I guess it makes sense, like, if you actually do the math. Like,
Yeah, it does make sense.
days go by pretty fast.
They do be cruising.
And I'm only 8,000 of them old.
Yeah.
But it motivates me to actually, like, get stuff done and learn new stuff.
Well, do you have a quote or anything that motivates you? Do you have stuff that, like, other than seeing that poster counting down to your death, does anything else motivate you?
I mean, yes, just existential dread. No, I do a lot of things to try to keep focus. Like, you can see that on my home screen.
Yeah, I can.
Yeah, little, like-
inspiration is.
Well, yeah, it'll just like give tiny little quotes throughout the day.
Okay.
And some of them are awful, but some of them are like, okay, I relate's deep.
That's good.
But then also, do you know what like memento mori is?
Mm-hmm.
Yeah, we're about to go into a deep philosophy rat.
Yeah,
like,
this is no longer
rabbit hole.
science. This is philosophy.
Stoic philosophy.
Yep.
Yeah, so memento mori is like, I don't know the exact translation, but it basically means remember you are dying.
Yeah.
Something like that. So it's just like being present to the fact that you were one day closer to your death than you were the day before. So live today as if it might be the last.
Which is a good mindset, but also like, don't climb buildings.
Why not?
Well, that's a preventable death.
I know what you mean. Yeah, but like, you know, it's not that memento mori means avoid death. It means live as if you will die.
Yeah.
And so like make the most of it,
Mm-hmm.
even if you are climbing a building, though that is ill-advised. It's like unless it's on a ladder.
Yeah, that's reasonable.
But like, I think I've made the most progress in my life counting down the days until I die. That sounds very morbid, but like, I'm a lot more proactive to trying to learn.
Well, it's like seeing this countdown. Well, not even a countdown. That would be even scarier. Countdown, just a Nixie clock, just counting down to my death. But yeah, seeing this, percentage done, it's like, okay, I have only gone this far in my life. I still have all this room to grow and make things better for myself and the world, and make it, better place.
I know what you're talking about. Yeah. It's definitely, it helps me get up in the morning. It can be like, all right, this is what I got to do if I want to get something done. Like I wrote it down in words the other day, like why I think engineering is so interesting. It might be in this notebook. I think I wrote it down yesterday. It was like, I want to build creative and impactful things. I
Yeah,
think that's
yeah. Well, I think that should be a very big motivating factor for a lot of people. But there's a lot of people that are in it just for the money, which, like, valid, okay, as long as you're being ethical. But there is a fair amount of people that are in it for the money.
Yeah, I said like what I want to do this year. I said I want to learn how to create amazing things.
Amazing things. I think you're on track for that. I think you're doing good with that.
But like, yeah, I guess that like, what do you think qualifies as like amazing in that like very loose definition? Like, I'd say something amazing would be Starship.
I think it's subjective, really.
It's very subjective, and it
Yeah.
doesn't have to be something that big, but it's something that feels like it's changing the industry or something like that.
It doesn't even have to change the industry. It can just change your life, as long as it doesn't affect people negatively.
Like,
right?
as long as it has some kind of little paradigm shift.
Mm-hmm.
Okay.
I think like
A
I don't
personal paradigm shift.
know. Yeah.
Okay, I can get behind that. Which is why I think the next step for my personal paradigm shift will be a bipropellant system. Solid motors are cool, but I really want to build a liquid system.
A liquid system would be awesome. I think at the U of A hybrid system comes first.
You think?
Oh yeah, hybrid is definitely easier than liquid.
Yes. Yeah. It's just on this, like, I mean, funding wise, it'll be hard both ways. But I think just a normal pressure fed would match the difficulty of a hybrid.
Well, you can do pressure fed hybrid.
Yeah. But like, at that point, just become a solid or get rid of the solid and make it both. So
I guess, yeah.
I mean, okay, I do think they'll be similar in difficulty. And then I've started looking at injector plates and all of the fun techniques that are needed to actually make something like that. Like, I don't know the manufacturing methods at all, but like the actual physical reason for the geometries and stuff are like, you want to be able to atomize your propellant,
Right.
Mystify it so that you can get a better mixture and a cleaner combustion. And these geometries blow me away. Like the
geometry of the injector plates?
Not just the injector plates, like each individual injector.
Oh, okay.
So there's something called a pintle injector.
Okay.
You kind of saw it on my screen earlier.
I did, yeah.
So
I don't know what that is.
It's basically like, imagine you had a garden hose in a garden hose.
Garden hose in a garden hose.
Yeah.
Okay.
The interior one is for fuel. The
Okay.
exterior one is for oxidizer.
Gotcha.
And the interior one has a cap on the end that makes it like an inverse on like an umbrella that makes it shoot out radially.
Okay.
And so you'll have all your oxidizers going straight. You have all your fuel going out radially, and they'll like mix. And it allows you to get a more complete combustion. But if you look at the actual shape of this injector, I cannot tell you the manufacturing methods needed to make something like that.
Yeah, that sounds insane.
Yeah. And I don't know if this is true or not. Somebody told me from the Rocketlab, the welding techniques needed during the space race to make all that hardware no longer exist.
What do you mean?
Like, the skills just haven't been carried forward.
Oh, really?
Yeah.
Wow.
So like, it was so advanced and so difficult that we've kind of like forgotten how to do it.
Wow.
I don't know if I believe that, but it would make a lot
I mean, it's entirely possible.
I look at these geometries and I'm like, maybe. Maybe it's impossible now. Maybe we need a new kind of manufacturing method.
There probably is manufacturing methods out there, though, that have replaced this, like the welding skills that was required then. Because there's a lot of new technology that comes out in the machining world.
Like additive manufacturing with metals.
Yeah. Which I think is so cool.
Yeah. What is it? Is Neutron? Neutron's the 3D printed rocket? No.
Yeah.
Is it
It's
Neutron?
Firefly. Firefly does it. It's Firefly Aerospace that has done their...
No, Rocketlab has a 3D printed rocket.
Do they?
Maybe I'm wrong. Yeah, the Neutron rocket. God, I'm going to feel so dumb if I'm wrong.
I'm pretty sure...
It's the Electron, not the Neutron. Yeah. It's like
Electron is 3D printed.
Electron is basically like 90% 3D printed. Yeah, it is Electron. Okay, I'm not dumb. Yes, Electron with the Rutherford engine. And so when they had their first test flight, it was a big deal that the
I
rocket
think
made
it's
it
the
past.
engine that's 3D printed on Electron.
Engine powers. Oh,
I think Firefly made the first full um 3D printed. I don't know. Maybe I'm completely wrong.
all right. But like, whatever it is, I'll fact check myself later. It was like a big deal when this rocket made it through Max Q
Right.
because
Yeah.
they were worried about that this new additive manufacturing failing during the max pressure, the max stress on the rocket. Which, like, Max Q is such a weird phenomenon. Like, it makes perfect sense why it occurs, like mathematically and physically, but the idea of dynamic pressure affecting your structure is kind of like unintuitive to me.
Scowy.
But like, you are going that fast where like the air is basically like a wall.
Yeah.
But all these analyses that they have to do for these structures,
Mm-hmm.
they're basically, or maybe, okay, you need to make sure that once you're approaching Mach 1, that you're supersonic, that the density of the air is low enough to which the maximum pressure won't shear your rocket in half.
Well, you don't want your rocket in half. So, I mean.
Yeah. And so that's why you like throttle down a rocket engine.
Okay.
So that you go slower during that part of the flight. So you allow yourself to get into a region where the air pressure is lower.
Right.
So that you miss that maximum aerodynamic pressure.
And you don't rip yourself in half.
No, yeah, rip yourself in half, rupture the airframe, stuff like that. And it's a really interesting, it's a calculus problem, basically. Which I guess that's why we're taught it.
Yeah. It's crazy that, the stuff that we learned in high school and expanded upon in university, where you can actually apply it. Like in class, you're sitting there and the profs tell you, oh, you can use it for this. It's like, well, that doesn't really apply to what I want to do. But then when you actually get into like working on projects and stuff, you're applying it. It's like, yeah, they were right.
I remember first year engineering. I took it at Red Deer.
Right.
And we had this competition. It wasn't engineering specific, but it was like a rice carrying race.
Rice carrying race. Okay.
Yeah. So you were given a certain amount of material and you had to carry as much rice as fast as possible. And your score would be a combination of the two in whatever equation. And I remember using calculus to maximize the volume that we could use with the material we were given.
Oh, wow.
And we ended up winning.
And
then my prof told me I was cheating because calculus wasn't on the approved list of tools you could use.
Was basic addition on there?
Yeah. I thought I mean, let's say I could do the calculus in my head, then would I be cheating?
No.
No.
Also,
Exactly.
writing it out on paper, how is that even cheating?
I know. I think he was just kind of being like a bit facetious with it, but yeah.
Salty. He was salty is what
salty
that was.
that the engineers beat the science students.
Yeah, exactly.
But yeah, is calculus and I mean all of the theory that we learn in school is so immensely, I like to think of it like Lego. So I can take a little piece from every single class, put it together, and I end up with this tool that can solve any problem I really need.
Yeah, it's amazing. That's why they make us take, well, I guess not make it. This is why we take these classes.
It makes sense now.
Yeah.
When you're taking it, it's like, oh my God.
Yeah, it's like, oh, this is a drag. I don't know. I feel like when I get to 300, 400 level classes, it's going to be different. But
I only ever look back on classes with gratitude. I during, it's more like the dread, like, oh my God, how am I going to finish this assignment? But looking back, it's like, oh, I'm grateful that I had the chance to learn all this stuff.
Oh yeah, it's crazy. Like there's an infinite number of an infinite pool of knowledge out there in the world.
Yes, and we should get some of that knowledge to join our show.
Yeah, we should.
We have had some requests.
Yeah, and we will bring someone on as soon as possible. I think that would be
As soon as we get it figured out, because I do not want to be sharing a mic with you. I feel like that
it might be a little awkward.
it would be like we have to get really close to these mics. Like we'd basically be kissing in front of these mics.
I don't want to do that. I'm sorry.
I'm sorry. I mean, you're my homie, but I'm not going to kiss you on the podcast.
I can live with that.
Okay.
I think that's
No, but I think that there's a lot of people that know a lot more than we do that we could learn from.
Oh, 100%. I think this is a great platform for it too, right? Like it's I've distributed to SEDS. It's been distributed in Star. It's been distributed in mechanical
It's been distributed
engineering.
in Star.
Well, I sent it to Ethan.
Oh,
That's it.
okay. Well, it hasn't ended up on the Slack.
It was a very shameless plug, and like I just kind of sent it to him.
Yeah, people keep coming up to me now and they're like, "Oh, your podcast?" I'm like, "Oh, I guess it is getting around a little bit."
I mean, that's okay.
It's
that's
fine.
the point, right?
Yeah, that is the point. I do want to I think science communication is very interesting. Not even like topic, but like just being able to. I had a mentor, my last co-op, who every time I would go and ask him a question related to work,
Yeah.
we would do a 3-hour detour into like the origin of language, or what coherent light is, and I'd always ask him, I'd be like, or no, he would always say, he'd be like, the best way to learn something is try to explain it to someone else.
100%. I agree.
And if you can't explain it to someone else, that means you don't understand it.
You don't understand it fully.
Yeah, I guess fully, but like,
Yep.
Like you only reach that level where you could say it's understanding when you can explain it.
Yeah. Okay. I agree with that.
Yeah,
Like
and so
100%.
that was his philosophy, and so yeah, he would go and I don't know anything about the origin of language, but he would explain it to me for 3 hours straight.
Wow.
And I would try to follow along as best as I could, and it's like, yeah, it's a fun. The dialogue is very fun, and you end up learning a lot from it.
Well, that's what I like about having these advisors for Alberta Cent, right?
Right.
Like they are some of the smartest people that I've ever met.
Yeah.
The smartest people I've ever met.
Yeah.
They're great. And every time I have a conversation with one of them, I learn something.
It's very humbling. Like if you speak with an advisor, like you can feel like you 100% know what you're doing and kind of the roadmap you have planned, and you'll ask an advisor how they feel about this plan, and they'll send you in a completely other direction that makes way more sense, and you'll get way more done.
100%.
And it's kind of just like, how much do I actually not know, but like, do I actually know the best way to get to the goal I want?
Yeah.
And turns out no.
Well, and that's all part of learning, right? Like that's what is nice about having, these mentorships.
Mhm.
Like I had a mentorship between first and second year with Kirtan, and
Mhm.
he was my mentor through SEDS, and he gave me a lot of great advice. I had a moment where I was like, I don't know if engineering is for me. Like I'm like, I don't think I'm smart enough. I don't think I'm cut out for this. And when I met up with him in Toronto, he's like, dude, I remember having that conversation with you, and look where you are now. I'm like, okay, you're right.
Yeah, I do think the focus on, so like you come into second year engineering right off the high tail of first year, and it's literally put in your face how smart you are, like quote unquote how smart you are, getting like when you get split into disciplines.
Yep.
Because that's just the way it is at U of A.
Unfortunately.
The specialization does not happen until summer of after first year.
Yeah.
But it actually, the idea of not being smart enough is not even close to the case. Like, it is the difference of someone who will sit at a problem, experiment with all these solutions, and not being willing to give up, persevere through a problem.
Right.
And that is actually the qualities of what makes an engineer. It's not what grade you got, though they can be related. Like someone who perseveres is more likely to spend 20 hours studying one topic. But to think or to disencourage someone because they're not doing well in a single class or maybe in multiple classes, to say they're not going to have the good qualities of an engineer, it's so wrong.
Oh, well, I don't know about you, but I struggle with imposter syndrome.
I think everyone does.
It's well, it's either that or what is the other one? What's the opposite of imposter syndrome?
Ego.
It's something to do with ego. It's another syndrome.
I will Google this right now. But yeah, you were saying about imposter syndrome?
Yeah, I struggle a lot with that. It's like I know deep down that I am smart, but everyone around me is also smart. So it's like,
Yeah, and so that's where a lot of those first years going to second years kind of get tripped up, is everyone else is just as smart as me. I can't really stand out. Oh, I'm around the average in this group of incredibly talented people.
or
That
even
means I'm
below average. I was below average. Like I was like, this does not feel good.
Yeah, but like it's going to sound like a bit of like engineering elitism, and I don't mean it that way. But like a lot of people enrolled in this program are very talented. And it's not just because they're very talented people, not because they're in engineering, but they've got into engineering because they're very talented people. That's kind of how I mean it.
Okay, I think after first year that is the case. I think first year
After the
definitely
first-
weeds out
After
the
the
people
first
that
year
are,
purge.
Yes,
Yeah.
exactly.
And so that's why I say it's after first year that usually happens.
Right. Okay.
And so you end up with this feeling like I'm so far behind everyone else. But compared to everyone in first year, you're in the top 20%,
Right.
right? So you're actually doing amazing compared to everyone who started in the program. But just because you're only among the peers who are,
Have persevered to this point, right?
can be demoralizing. Yeah. Everybody deals with it, and especially as you engineering students are meant to be leaders.
Yeah.
So throughout your undergrad, you'll start getting more and more responsibilities. And it kind of gets to a point where it's like, oh, I'm no longer the person teaching. I'm supposed to be the teacher. And it's not gradual. It's literally like overnight. Your responsibilities change.
Yeah.
And that's where most of the imposter syndrome, I find, personally comes in. It's like, oh, now I need to be the person who knows, not the person who's learning.
Right. Okay.
But don't, like, you just gotta, and I think this, like, going through my own journey like this, it's helped me kind of realize what a leader is. A leader is not supposed to be someone who always knows.
No, not
but
at
someone
all.
who's always willing to find out.
It's someone who is willing to find someone who knows. It's someone who's willing to enable people that do know.
Yeah. And so that's kind of helped me the most through, I guess, third, fourth, and now to my fifth year with imposter syndrome, is like, oh, even as someone who's supposed to be a role model for others, I can still learn and grow.
Right.
Which, I mean, saying that now makes perfect, like, it's common sense, but just in the moment.
Yeah, I know exactly what you mean.
Yeah.
Yeah.
So I know you're feeling stressed right now, but don't worry.
It's been a very stressful couple of weeks. Roll with the punches.
Roll with the punches.
Keep on going.
And you can always come vent on our podcast. Maybe not vent, but we can just have some nice banter.
Yeah, that's one of the best parts of the week, you know? Yeah.
I always look forward to our Thursdays. Or
Tuesdays.
Tuesdays. Oh, my God.
Tuesdays.
Maybe I need more Tuesdays.
Tuesdays record day. Yeah, but we're getting close to our deadline for RGX.
Yeah.
It's coming up.
And I was actually very proud of you today with how fast you were able to find a solution to your problem.
Well, it's so...
Like, it's a prototype solution, but, like, you went from oh, this isn't going to work. Oh, here's a solution, and had a model for it in like less than 30 minutes. It was incredible.
Thank you.
Like, I think today you embodied the spirit of throwing the kitchen sink at it, like in a polite way.
Yeah, it was kind of like we got to the point where it was like, well, this is not going to work the way we want it to. We need something, and we need something now.
Mm-hmm.
And
then Connor went and was disembodying old 260 projects to find gears that he could turn into a makeshift gearbox, and then tape to his model.
Hey, it worked.
It worked.
We got the RPMs we needed for our plate, and it moves up and down.
Yeah, so I was curious because it was like a 2.5, I think I estimated it as gear ratio. That's going to be your max speed.
Yep.
So you can still get the other speeds you require by just going at a lower. Yeah. Okay.
Yeah, which is very nice.
Very nice. And then let me know if you need help like designing a gearbox or anything.
I'll get most of my Mechie team to design those.
How many Mechies do you have on kind of?
We have Tom, Saksham, Spencer, Lauren.
Oh, so it's everyone's a Mechie.
Pretty much.
Pretty much.
We have 2 high school students.
Right.
Priyanka is Compy.
Oh, okay.
Emily is in marketing. I'm Mechie. Lauren's Mechie. Saksham's Mechie.
I think you're just going back to
we're most of us are Mechies. Yeah.
Which that's a-okay because Mechies can do anything.
So yeah, that's the nice thing is that this experiment is giving me exposure to like electronics, mechanical side of things, project management side of things. Like I'm getting everything thrown at me, and it's like I have a team that is capable of assisting and developing their own solutions, which is good to have, and it's nice when everyone wants to be there.
Yeah. How busy are your Saturday work sessions?
So the last Saturday was probably the busiest we had in a while. Life gets busy. So I had my brother's graduation a couple of weekends ago. Lauren was camping. I was in Toronto. So yeah, stuff gets done, but stuff doesn't get done to the degree that it normally would if we were both there. And we were both there that weekend. And we made some pretty decent headway. We were like, okay, stepper motors aren't getting the RPM we need. What do we do to fix this? Brush motors. And I'm like, okay. DC brushed. Tested them. They did not work. The torque wasn't enough, unfortunately. Would have been a very nice solution, but then I'm like, okay, well, what about brushless? No, we need a power supply for that. Okay. What else can we do? We can use the stepper motors we have in a different way than we're using them. Gearbox is one of them. We're thinking maybe a ratchet system, spring-loaded ratchet system.
I think I told you kind of that idea today. I think that would work, though you'd have to be pretty, specific with your code. It'd have to be pretty precise because you need to tighten it in the direction of the ratchet with the stepper, and then take all the slack or give it all the slack back into whatever tightening device before you release the ratchet.
Well, you could just release the ratchet and it would spin freely as long as you're not putting a current through.
In the stepper, there still is a bit of a feedback on it.
Yeah, but not enough.
Okay,
if your spring constant is large enough, that's negligible.
Okay, yeah, that would be a good solution.
I think we're gonna do the geared solution though. I think that's probably best.
We do love our gears.
Mechie.
No, I just this weekend I was doing rocket stuff, and it felt like all hands on deck.
Yeah, you guys are coming up on your launch.
No, not just for us, but for you guys as well.
Oh, yeah. It's. I think a lot of the projects right now that I have on the go are all hands on deck.
which is therefore the stress.
Yeah.
But yeah, Star was all hands on deck as well this weekend. We finally have all of our fiberglass components, aside for one little step, which I can explain later. But all the fiberglass components are built.
Okay, that's good.
So next steps are cutting to length, sanding so that everything fits, because even though like we like to design in a perfect world, when you're dealing with epoxy resin,
It does whatever it wants.
It just
It's
expands
not-
to
yeah.
whatever size, then that's the size, so you got to sand it down. But the last step we actually have with fiberglassing is called tip-to-tip glassing.
What does that mean?
So it is a technique that you do for fins
Okay.
to increase their strength and their rigidity.
Right.
So we're using carbon fiber fins. They're a cropped delta design. So they're
Okay.
just a triangle with the
Yep.
end cut off. And we're not doing what's called through the wall mounting. So they're surface mounted fins.
Oh.
So there's no fin can. They're just mounted to the surface with JB
Okay.
Weld. And so to increase the strength, what you do is you put 3 layers or varying layers. We're doing 3 of fiberglass of varying lengths along the fin's body and the other fin. So like if you have the
Okay.
L, you have 4 fins, you'll have like an L-shaped quadrant. You'll maybe start a third up one fin, glass to the other third of the other fin, 2/3 with the next layer of fiberglass, and then full tip to tip with the last layer.
Okay.
And it will actually, like, we did it with with 1/8-inch plywood, and you can stand on these fins.
Wow.
The 3 layers of fiberglass make it so strong you can stand on the fins. Without
That is
breaking them.
crazy.
So yeah, that's the last step we have to do, fiberglass wise, and then all that's left will be machining bulkheads. So that will be all CNC.
Oh, nice. You just finished that training up in the garage, right?
I finished a little while ago.
Okay.
Yeah, machining circles sucks. we
What lathes are for, my friend.
well, we got them to get a chuck.
Oh,
So-
perfect.
So, there's an 8-inch chuck in Elko now that we can use. And that'll be super helpful. But we have like 80 millimeters of aluminum stock, and we need to use 60 of it.
Oh, that's okay.
And it's 6-inch aluminum stock, but we need to machine it down to -2 mils all the way around to fit inside the coupling tubes.
Okay.
So like our payload bulkhead is 6 inches, so that one just gets chopped and it'll work. But the other ones, you need to machine the outside a little bit so that they're a tiny bit smaller.
I can do that on the lathe.
Can you?
Fun fact, yeah.
Please. It might make it easier. But
Well, that's if I go back and get the physics thing, but that's another story for another day.
But if you want to machine something that thin from the stock, like it's a thin stock, right? We're not going to take anything off height-wise. We just want to take off the edge.
Right.
So we're going to have to clamp it really high in the
Chuck.
chuck, machine off those 2 mils on the outside, flip it, put it back in the chuck upside down, and then machine off the remaining,
Yeah. Yeah.
which, well, you'll have to be pretty precise with. So, I mean, that's all in the work holding, like setting up your work coordinate system. So I think it's not impossible. It might not even be that hard. It might just be like an extra 30 minutes of setup. But
Well, if you have, why don't you do 15 mils hanging out of the chuck, or sorry, 15 millimeters in the chuck?
it's 10 mils thick, the bulkhead.
Yeah, but you can machine the whole thing, right? Is it one large thing of stock?
It's 80 mils of stock that we're going to
Yeah.
slice into like 12 or 10.
Well, get someone to put that in the lathe for you and
Just turn it on the lathe.
turn it on the lathe, bring it down to size, and put the rest in the mill, and you can slice it.
Yeah, that's possible.
I don't know. That's just me throwing it out there.
If you-
I don't know.
If you want to lathe our metal, be my guest, please.
Yeah. We'll see what happens, I guess.
No, but like that's basically all that's left, and then our rocket flies.
Are you going to launch?
I am unfortunately not going to launch.
No.
I have well, one, there's more senior members who get to go.
Aren't you a lead?
I am a lead, but there's more senior members who are graduating, so they get to go.
Oh, okay. That makes sense.
And I have something else planned that weekend.
That's reasonable.
I have a game.
A game.
Yeah.
Oh,
For that thing.
for that thing.
I mean, yeah, I'll just say I'm a cheerleader, so I cheerlead at Elks or at football games. So I have that planned instead of lunch.
I mean, that's reasonable. That's a cool thing. We'll come out and watch sometime.
Please do.
Yeah.
I need all the fan support I can get.
We'll be cheerleading the cheerleader.
I need someone to inflate my ego, please.
Well, from what I've seen, and the one time you threw me up.
I'm glad you didn't hit the ground.
Yeah, me too. That would have hurt.
Because that was after karaoke night. So
That was during cake day
and
that it was successful.
successful with a very big asterisk.
Yes. Very big asterisk. Karaoke night was another story.
I think Alberta Sat should be forced to go to karaoke night every.
We should do a karaoke night on Wednesdays. We should do Wing Wednesday with karaoke night.
Do you know anywhere in the city that has that planned?
I don't know.
We'll find a place, or we will make a place.
We could do Wing Wednesday at my house, and
Steal this mic and make karaoke night.
The Mechie Club has a karaoke machine.
Okay, I'm gonna put this in the Alberta Set calendar, and everybody is going to be forced to show up or be kicked out of the
All
team.
70 members need to be there.
Minimum. I think we have 115 members, so I hope you have a big backyard.
Talk to my grandma. Maybe we can ring it out there.
I do have an. I mean, it's 2 hours away, but I do have an acreage,
Oh,
so that could be. Maybe
that would be fun.
camping night.
Bush party.
Have you ever? Okay, I'll take this offline.
All right. Well,
Peace out, Space Cadets. Thank you for listening. We will be back next week
all right. See you everyone next week.
for
Thank you
our
all.
therapy on Tuesdays.
Blast off banter therapy sessions.
All right, peace
All
out.
right. Cheers.